Thank you for coming to all of you. Um, yeah, I will talk a little bit about my experience with Apache Beam and like what the fun things you can do with data, and well, like, I think we'll get started. So, the first of all you need to have a focus on the right window, and then I want to start with just like kind of funny, interesting example, and I just want to ask uh, this little thing. It could be anything. Could have been Alexa. Could have been, but in this case, it's a Google Home. And then you can ask the kind of the question, because how many of you have this Oslo City Bike similar thing? We have something in Oslo which is called Oslo City Bike. I've seen something very similar in Madrid just today. It's like bikes you can just pick up and you can bike around and stuff like that, right? So kind of dream scenario. You can ask like, "Hey Google, what's the bike availability next to my home?" See if it works. "Hey Google, what's the bike availability next to my home?"
There are 5 bikes available at the moment. Based on historical data, the availability for this station will be decreasing for the next hour. I would suggest getting your bike within next 10 minutes.
Nice, right? But the thing is, it's kind of the dream, because what it usually happens is kind of different. So let's rewind a tiny little bit and just go back and like kind of think of how it all started. Just a disclaimer: I don't work for a project working on Oslo City Bike. I don't work with anything. I just needed some data to play with, so I ended up there. I'll tell you a little bit more in a few minutes. So let's rewind. This is the Oslo City Bikes. They look like this. This is the same thing you see in San Francisco, and this is the picture I took today in Madrid. It was somewhere close to the city center, I think. So those bikes are there everywhere, right? And then you always have an opportunity. You can buy, like, I don't know, I guess it's the same here, that you can buy a kind of membership thing, and you have a card, and you can just like beep and you pick a bike and then you travel around, and it's very nice, right? It's very convenient. You can this is how Oslo City Bike sells their bikes to you. You have like nice nature, beautiful green grass, and like, summer days, and everything is happy. And this is pretty much how it looks, well, at least half of the year in Oslo. The other half of the way it looks, half of the year in Oslo, it looks like this, which is a little bit less nice. But well, funny enough, they don't have those pictures on their side. But okay, let's go back to the nice weather. So the nice weather is, it's really cool. The idea is great, right? You have a membership, you just go and beep that thing, and you can get a bike, you can travel to wherever you want, you park your bike, and it's perfect, right? But the thing is, sometimes the thing is not really like this, because the stops usually don't look like this with all the bikes and everything ready, waiting for you. Sometimes they're full, so you cannot park your bike, and sometimes they're empty, so you cannot get any bikes. And then you start kind of thinking, like, what can I do? Because like the moment you get to pick your bike and start biking, there are no bikes, and then you get a little bit sad. And then you start like, okay, fine, you know what? I know IT. Everybody stand back. I'm gonna fix that. Uh, and then you start kind of thinking, what can I do? And the kind of, to illustrate the thought of like the process of thought, I have a little slide here. So you start planning, you start thinking, what can you do with this thing? And then you start like, okay, well, what should we start with? Well, we don't have any bikes. Well, that kind of sucks. Um, where can I find one? Well, really, I don't know. Because, well, you have an app that shows you real-time things, but it doesn't show you how it's going to be when you, like, in those 3 minutes until you leave home and get to that station, right? And that sucks. And then you are like, okay, can I use the app? Well, I mean, not really. Because, again, it doesn't show you right now, right there, and you're at home, and you still have like 3 minutes walk to the nearest station thingy. And by that time you walk, everything is gone, or everything is full. Um, okay, so what can we do? We can use public API, because, well, some of the APIs, they actually, some of the services like this, they offer public API. So I don't know how it's here in Madrid, but in Oslo, they actually offer pretty simple, very basic API that gives you a bunch of JSON data. Well, maybe that might work. Okay. Um, can I collect historical data? Because I don't really want now picture, because that's all those APIs give you now picture. But I don't want to do that. I want to have like the thing you heard in the beginning, saying like, well, based on historical data, based on statistics for the last couple of weeks, the availability is going down or going up. I would suggest you going and picking up your bike earlier or later and stuff like that. So I would like to collect some historical data. Okay, fine. How do I do that? Do I write like Python scripts? Do I do like, well, put it in a data warehouse, go full enterprise? I don't know. It's just like, it kind of sucks. Because, well, all those things cost money, and, well, you end up like having a huge, everything starts, it started for me as well with a tiny little Raspberry Pi, but then kind of you realize that Raspberry Pi is not enough. So then you have another one and another one, and then you have like a huge server rack running at home. The good thing, you don't really have to pay for like for warming up your house. The bad thing is a bit noisy. So then you're like, okay, fine. What can we do? Should we write something custom? Should we write like a Python scripts and everything? Yes, you can do that, but then it's like it's really hard to maintain because it just grows and grows and grows and grows. Can we use something that's out there? And that is how I kind of got introduced to Apache Beam. And then you were like, oh yeah, well, yes, that works. I found something and it works. And then, well, profit. So, just a couple of words about myself. David introduced me already. I work for a Norwegian consultancy company called Compitas. I work a consultant there, mostly with Java, the architecture, stuff like that. I am quite involved in JavaBean. I used to be leading that. JavaBean is Norwegian Java user group. It's just we have like our own name instead of Madrid JUG or anything. We have like Norwegian JUG, which is called JavaBean. And I used to lead that for 2 years, and then we have this thing that after 2 years you have to pass it on to someone else. So I passed it on to someone else, and then I took over JavaZone, which is our JUG organizer. So it's pretty big conference. You probably have seen like some of our promotion videos and stuff like that, because this is what people usually it's like, oh yeah, I've seen those videos. If you haven't, have a look. It's a tiny little conference in Oslo. It's around like 3,000 people for 2-3 days. So, well, this is pretty fun thing to organize, and it's all done by volunteers on like on spare time. And well, I'm also part of the Java Champions, the group. I became part of that a bit more than a year ago now. So enough about me. Let's talk about the architecture, right? Because this is what we do. We're IT people. We want to solve the problem. We want to make those bicycles be available at the right time at the right place. So you end up with something like that, and it's like simple version would be without streaming, would be just this, and this is what you end up. This is what I did first. I did that thing on my Raspberry Pi on a tiny little machine running Linux. So you have some kind of cron job that kind of runs every whatever. So mine runs every 15 minutes and dumps the data. You put it on files, and then you have something else to pick up those files and do something with it. So you can use Apache Spark, you can use something else, doesn't really matter. You put it in some kind of data warehouse, so you just store it somehow, and then you look at that thing somehow. So it could be a Jupyter or whatever, it doesn't really matter. So the point is, you dump data to files, you process files the way you want, you store them in a way you want, and you show it in like graphs or whatever, right? But then one sunny day, one great, fantastic day, it haven't happened yet, but like in the future, when Oslo City Bikes will offer streaming of data instead of showing like kind of half-stale data, then you can do something similar, right? You just do some kind of queue of some kind, RabbitMQ, whatever, put it in a Storm or anything else, and then you put it on a dashboard that shows you like the availability, real-time picture compared to whatever and stuff like that, which is cool, right? Seems to be working, and this is what I started with. And then I was having this cron job, dumping data every 15 minutes, so 4 times an hour, just dumping the data to to the drive. But then you get a little bit sad again because it's still your Raspberry Pi and it still runs on your table, and sometimes it kind of dies, and sometimes it's the network is down or things like that, and then you lose a lot of data. You kind of want to have it on more on available all the time and things like that. So you kind of want to not to manage all that yourself. But well, we'll get back to that later. First, a little bit about Apache Beam. So I mentioned that already. It's open source. It's free, open source, the whole code and everything. It's been open sourced by Google, if I remember it correctly, and it has two ways of doing stuff. So it can do batch, like with files and stuff, and it can do also streaming. It has two APIs, two libraries, two APIs. You can do the same thing in Python. You can do things in Java. You can guess which one I chose. Well, I mean, I like Python as well, but well, Java is actually for now seems to be even more robust. So try that one first, and then you can put it in whatever you want. You can do it locally, just run it on your machine. You can put it on some kind of cloud. Or you can do it some other like on-premise clouds and stuff like that. All right. So back to the architecture, right? This was the idea. So you have the cron job, or here you don't really have to have a cron job. It just comes in, and then you process data. If you replace that thing with Apache Beam, you don't really have to have two lanes. Now you can actually join them together. So you just have like Apache Beam here. That kind of can consume both files and streams, which is cool, right? Then you don't have to have complexity of two things running here. You put it all together. All right, that sounds good. And then we go back to this kind of don't want to run that thing on my own machine kind of thing. So if you want to put it in the cloud, in this case, I chose Google Cloud because Apache Beam works really, really smoothly on that one, but it pretty much should run on any cloud, and it should work and without any problems and everything. Well, since Google made all that and created all the whole thing, it runs really smoothly, and they have like a managed version of Apache Beam on their cloud, so works for me. And well, I mostly work with this cloud, so that was kind of given for me. But again, you can put it on anything else. So if you're gonna go with any kind of cloud, you will go for some kind of cloud function. So serverless. In this case, it's a cloud function. It's called lambdas. It's called on the AWS. It's called, I think, like functions in Azure as well. So you put it something. You use something to put it on files on like some kind of bucket of some kind, and then you use some kind of queue. Which is publisher-subscriber kind of queue, and then you put that thing into Apache Beam running on your either in your Docker container or running already managed for you or anything else. You put it in some kind of database, and you look at it somehow. Okay, cool. That's really nice, and it's like, I mean, the thing that was really my experience, like first time trying Apache Beam, and then I had like one thing. In the beginning, it was really kind of difficult to get the idea of what actually Apache Beam is doing. And you're like, well, I have these examples, it's counting words and stuff, but I didn't really understand what is it, what's it about. It's like the example that you get is like word count. So it has like a bunch of files, it eats them all, counts all the words in those files and spits the out in the name. So the truth was actually, I was kind of, okay, I want to learn Apache Beam. What do I do? And then I realized that I have this little project kind of running on Raspberry Pi, dumping all that data of city bikes. And then I was like, I can put those two together. So let's talk about Apache Beam. Let's talk about pipelines. So pipelines is something that is that's a kind of concept of Apache Beam, the way you process things. It can be, it doesn't matter how you put things in a pipeline. It could be like streams, it could be batch jobs, whatever. just you put it in a pipe and then it kind of gets processed. So, what is a pipeline? Well, according to Wikipedia, is that. Basically, it's just some kind of directional graph. So you have something here getting in, you have something getting out, and there is some things happening to it. Very simply put, right? And then you can sometimes put things together from two different pipelines, or you can split them up, or something like that. In this example, it's super simple, so you don't really have to do that. So here it's just one straight line going like input, do some magic to it, and output. So a very simple pipeline, right? This is the data you get out of the API. So you get it has two endpoints. So one of them gives me all the data about the station. So one particular stop or like a station where you put bikes or pick up bikes, it has all this information. So it has some kind of ID. It shows if it's in service or not. It has some kind of title, subtitle, number of locks, and so on. So it has some kind of geographical coordinates, and then it has even like more fine-grained, really nice coordinates. So you can actually draw a rectangle there, or well, whatever. Which is cool, right? And for each station you would have this. And I think there should be around between 200-300 stations around the city. So 200-300 of those. And then you have per each station, every, I think, 10 minutes, you get new data looking like this. You have the ID, which is the same as there. You have the availability of how many bikes are available. Here you have no bikes at all, but there are 10 locks. And there is also some kind of overflow capacity. So basically, so you can actually set bikes there, even everything is locked, so they don't use all of the station. Which is cool, right? But then, imagine you dump all this data 4 times an hour for a few months, and then you have a huge amount of files, and then normally you would end up doing like writing a Python script or something to parse all that, and it would suck a little bit. Because you have to do that, you have to run it, you have to have a place to run it, you have to have your Raspberry Pi running, and well, it's kind of, that's probably the reason why it died the first time I tried to do anything about that. What happens is that I want to go from those 2 files with all this data and everything, to this. So, well, this is auto-generated, so it doesn't matter. Then you have an ID, you have availability of bikes, you have availability of locks, and this is, I don't really use that much, this kind of data, but, well, it's there, cool. And also I want to know when the data was generated, because this thing, it's like a ginormous, enormous, huge, super huge JSON file, and there is a timestamp at the bottom saying like, well, this data was updated, blah. And it's kind of really nice if you have an app that kind of gets the information right there and right now, but if you do it with historical data and you want to store it, it kind of sucks. So you want to go there, and then you want to transform your data from that thing to this. What you can do is you can use Apache Beam, what I did, and what I used for this is something called pardoes. Pardue is a parallel do, and it is something that lets you process things in parallel. Surprise, right? It's pretty. Most of those things that I'm going to tell you are quite obvious for people who have done a lot of like functional and like programming and things like that. If you haven't done that much, it's a little bit confusing in the beginning. So the data to be processed by this thing should be not depending on each other. So bunch of files with historical data from the bikes is perfect for this, because, well, I mean, I can read it by like 10 different machines and put in the same database, and the data won't change, right? But then if you have some kind of data that needs to be dependent on some other data, it won't work. So then you have to process it in one line. Those parallelize really well. The code that I wrote is super little exciting. It's kind of almost boring, And but that was kind of the whole beauty of it because it was so simple. Because I had this kind of aha. From time to time, we would just have this kind of feeling, you know, it was like, oh wow, this is too scary because this is too simple. But well, it was. So you just create a tiny little class that has the collection. The collection is something that Apache Beam is very fond of, and well, it's one of those things that you will see. This is kind of one of the terms they use a lot, and you put all that into a collection which is a linked hash map of the stations, and here you do some magic in this class, extract from JSON, and basically what it does, it just extracts from JSON, puts it in some kind of data structure, and passes it on. And then inside there, you would also do some kind of manipulations. You would transform things, you would get some data from the other files, you put some more data into that structure, and you can basically end up joining two JSON files in one, right? And add some more metadata, but because I have all the files that getting dumped every 15 minutes, it has a timestamp in the name. So I pick actually the timestamp from the name, and then I use that for the database. Okay. So now I run that thing on my machine, and running on that on my machine is pretty simple. So you just use Maven because it kind of auto-generates Maven for you, or if you just download the example, it will have Maven in it. I think it also has Gradle. I don't really remember. But well, the thing is, again, it's kind of getting really boring, right? You just have, well, I'm going to run some compile stuff, and then pdirect runner. That means that I'm running it locally on my machine. So this is a setting to Apache Beam. And then I'm telling it also where the main class is. Well, that's that one. And if there are any arguments to that class, in this case, it's some kind of input file because, well, in this case, I'm just having only one simple file. I don't have the bunch of files. If you want to have a bunch of files, I think you can pretty much say source star.txt. I think that's what I ended up doing at the end. And you want to somehow dump data locally, because for now we're running all on that machine, we process all that thing, and we write to file. We don't use databases or anything fancy. When I ported the same thing to the clouds, I'll jump back and forth in a second so you can actually see the amount of things changing, but pretty much it's the same thing. You change this one from local to data flow, because the managed version of Apache Beam is called Dataflow. Again, main class, arguments. In this case, you have a little bit more arguments. You say which project on your cloud account is used, and then you have some kind of input files. So this is basically picking up stuff from a bucket. There you go, the star thing. So I pick up all this data for 2018. Staging location is something that Apache Beam needs, but you pretty much won't see that much. You will see a bucket there, and it will be full of some kind of files, but you don't really have to think about it that much. Output is not really that you really need to do anything about either. And then you put temp location is also something that is needs internally to put some temp files somewhere, so it's fine. Data flow runner, so you define a runner, and you need to specify region, because because in this case I was putting data into a database, and if your database and your Apache Beam job are in two different regions, it won't work. It just fails with some mystical, very weird error. So it took some time, and then we were like, oh well, okay, we just need to do that. So going back and forth. So you see it's pretty much the same thing, right? The first one is changing, and you have some extra things that, because, well, you don't have the file system, so you need to have some kind of temp locations, temp buckets, so it would put it. This is how it looked when I tried to put it on the cloud. So again, the cool thing is that if you do it locally, it won't show you the fancy graphs and stuff. If you put it in cloud, so I guess this is kind of way of making them like the cloud more or whatever, they actually draw you a fancy, cool graph. And as I told you, in this case, it's very kind of do one thing, another thing, and done. It's not like super fancy joining and splitting pipelines and stuff like that. So it's very simple pipeline. And what happens is that the cool thing is happening here because I have quite a few files. I think I had like data for 4 months or something. And well, count it for yourself, right? 4 or 5 months of data, 4 times an hour, 24 hours a day, and so on, so on. So it's quite a few files. The cool thing was that I started the job and it was like running for a little bit, and then I realized, well, there is too much of it, and then it kind of upped the number of workers, and then it worked for a little bit more, and it's kind of automatically just upped the number of workers on machines parsing and running that code to I think it was like 16 or 17 or something like that. And when it was done in less than 15 minutes, it just like everything was killed and everything was nice. So it just started a bunch of virtual machines for me to do the processing, and when it was done, it was just like take them all down again. So if I would run the same amount of files and everything on my machine, it will take quite a few more minutes, and it will also be it will be probably a little bit warm. And the code and the pipeline and everything was not like super optimized. I was just like trying out things, which is cool, right? So the thing is, the whole thing seems to be taken, elapsed time 18 minutes. And by that time, it also dumped stuff to the database. So I didn't really have to set up anything. Amount of data is not super impressive. It's like 40 megs. But it generates quite a few rows. So you have 1.1 million rows. So, well, I mean, it's not really big data. It's not even little big. But, well, it's a kind of respective number of rows in the database, right? 1 million rows, yeah, well, that works. And then you were like a little bit like this. You were like, oh, that was it? That's so easy? And it kind of is. And I had this kind of, exactly kind of this face a few times while doing this thing and trying it out, because I was like, okay, that was it. I don't have to parse everything myself. I don't have to like make sure that everything runs myself and everything. No, it works. Okay, cool. And then I told about that to a colleague of mine. So I was like, oh wow, look at this super cool thing. It was like it just works, and we just built this simple pipeline, and it processes stuff and dumps it to the database and everything. And then he was like, ooh, I know about this cool database, which is also open source and like free and everything, called ArangoDB, that is able to pretty much consume all that data from anything, from files you generate, or in this case it was BigQuery. So this thing is actually, it says BigQuery. So you can just create a connector and it will just eat all the data, consume all that, and for example generate maps. So then I could actually generate my own maps with some kind of average data of availability and where it is, and just put it on map just like this. Because he was like, okay, give me access to the thing, and then he just created his little thing that would just make it work. And then you kind of expand the pipeline, right? So instead of just dumping it to the database, you actually split it up and you put it in the database and you send it to ArangoDB, and then suddenly you have much more data out of the box. And everything is, you're still running on open source, free kind of software, which is really cool. But then, if we go back to the picture, to the architecture, this works, right? But then, what about the streaming part? Because till now we've been working mostly with batch, with just files. So I have like a bunch of files and I process them and everything. So what happens if I do streaming? If I do streaming is, well, simple as well. And then I realized it was very simple. But how did I get there? So the way I got there is going from, the batch looks like this, right? Because you have a bunch of files. So here it's just per day, I had per hour, doesn't really matter. You just want to go to this. And it's just data keeps on going and going and going and going. And how does this work? Well, the thing is that you can have some delays. So the things will be different when you do streaming. So the data concerning 8 o'clock in the morning for this bike station here might arrive at 8 o'clock, which is cool. and then it might arrive at 8:30 because, well, because reasons, because internet, because the package got lost somewhere, or it was the station was down, or something like that, or the data could even come in at, well, around 2 in the noon. And then you have to handle that. So one beautiful day, whenever Oslo City Bike kind of offers this kind of streaming possibility, what can we do? Well, I kind of looked into that as well, and then I looked into how this thing handles, how Apache Beam handles the streams as well. Um, First, we need to think what we want to do with our data. So what are you doing? So in our case, we're doing kind of this thing, but like in the most simple way, you just have some kind of data in some kind of way, you convert it to some kind of other way, and you store it, right? And then you can also do something like aggregating and reducing data. You pick those two boxes and you put them in one, so you kind of count things or whatever. And then you can also do like super advanced, fancy version of the same thing, where you do all of the above plus a little bit more, and then you store data, right? All that you can do with streaming. And when you do it with streaming, you have to. There is a little trick that you need to kind of be aware of. You need to think of windows. So you put. Normally, you would create windows for like time windowing. And then you say, well, I have a window of data coming in between 9 and 10, 10 and 11, and so on and so on. So that's how you separate them. And then when you pick all that data, you would put it in a proper bucket. So the moment it arrives, you just like look at it. I was like, oh, this is data from 11 o'clock. Fine, put it there. Oh, this thing is the data from there, and then you put it there. And then you kind of keep on storing in different buckets, and you kind of aggregate them later. Another thing you can also do kind of windowing depending on data. Typically, you just think of web application with cookies with sessions, and you want to do you want to do aggregation based on a session, not on time, right? You don't really care when the user did that, but you want to know that this particular user did that. So then you can do sessions depending on not on time, but on like on a session, which is also possible. And then you can do some magic. And then this is again kind of really, at some point, gets almost scary how simple it was, and when I tried to make it work. So those things that I really liked is that, like for example, you can look at past 5 minutes of my window every minute. So every minute I look at my last 5 minutes, and then you can just do like this. You just like events. You just apply a window. And that sliding window of 5 minutes every 1 minute. It's almost like the way you speak, right? And it just returns you that. And again, magic. And then you can do things like you can actually write queries. For those of you who are really big fans of databases, you can actually write SQL or SQL-like queries on your data without actually having a database. You still have some kind of data structure, but you can actually write a join like this, and it will still work, which is kind of still cool. I mean, well, some people don't like writing queries, some do. So if you're that way inclined, have fun. And then, well, monkey again. Then you're like, wow, this is very simple, and this just works. So we kind of ended up going from a Raspberry Pi and like bunch of data and storing data on the file and like what do I do with this thing, to kind of automating the whole data flow without really having to think that much about it. And the other thing is that I told you is that I used examples of Google Cloud, but it doesn't have to be that. You can do it. You can run the same thing on pretty much anything you want. So this is the Google. So then you can put things on Amazon. You can put things on Hadoop. This is Kafka, and so you can both read and write to data to the data on pretty much any kind of cloud, and it would still work. And then you can swap the things, and then you can say, well, you know what, I I'm getting some data from Google Cloud, some getting from some of this from the S3 buckets, some of the data is local, and it will still kind of put all those data together and just magically read all that, process it, and store it wherever you want. Yeah, and then the cool thing is that the most of the code, and I can show you a little bit of code, and it's not that much really code, but the examples and the example I used for this presentation is online, and it's just you're welcome to have a look, you're welcome to play around, you're welcome to, well, if you see something, just send a pull request or make some more fun with, or have some fun with data, well, knock yourselves out. And well, this is pretty much it. But I think now I will just show you real quick some code, and I would like to hear your questions. I mean, let's do one thing, just to check. Put both of your hands up. Okay, they're working. Cool. Now you put one down. Cool. This is how you ask questions. So everybody's hands work. This is good. So now, do you have any questions, any comments, anything? While I'll we kind of like to see code sometimes. So, the cost for what? I think, yeah. Oh, yeah, of course, of course. To repeat the question, what are the costs for running things on the cloud? I don't really remember what it charged me, but I think for this 18 minutes of running things, it was like nearly nothing. It was like euro maybe or two. And then it like picked up 18 machines, processed all that, and kind of took them down again. I don't really remember what it was, but I think it was like around 15, 20 kronas, which is like divided by 10 approximately to get euros. So it's like 1 or 2 euros, I think. But I don't really remember because yeah, I think it was something like that. So it was pretty much nothing. It just takes for the processing power. So it just takes for those machines running. And I think it uses some kind of magic in the background. Since it's managed, it doesn't charge that much. And also they have another thing that if you're going to run it on Google Cloud, just think of it as they also have this thing that kind of sustain usage discount. So the more you run, the cheaper it gets. So the kind of to long story short, the answer is it depends. But I mean, the good thing, I mean, if you really want to, I mean, I didn't really kind of think that much about it. But if you want to make sure that you don't spend too much, you can put caps on the usage, and you can also use they have like a pricing calculator online. That just go in there and just type in amounts of data and everything. It should give you a kind of ballpark of how much it will cost. If you run because what I still have now running a cloud function, and I'm using some kind of bucket that constantly saves the data 4 times an hour, and it still runs. And I still don't remember if I got charged anything for that. It's like they charge for the amount of data you store, and it's like it's not that much. So I'm pretty much sure I'm running it almost for free. But I mean, like this is kind of game scale, right? And normally it would be a bit more bigger scale, and you would do, but still, it's not much. Any other question over there?
Regarding the point that you were saying that every minute you have a window for 5 minutes. So
Yeah.
This means that you are reprocessing what you have already processed, or
You might. So you just need to do some kind of. I'm not sure. Actually, I would suggest to look into the documentation and make sure it's giving you all the data for the last 5 minutes or all the new data. Since it's a stream, I wouldn't be surprised if it would actually give you only the new, like late arrivers kind of thing. Okay. But if it is, then you would just have to make sure that you don't overwrite data, or you just store it or whatever, because this would give you 5. Yeah, well, just have a look.
Okay,
It
okay.
should the API is pretty well documented, so I wouldn't be surprised if it just gives you new data only, since it's a stream. Any other comments, thoughts, feelings, questions, anything?
Thank you. If some crash happens suddenly in the middle of the computation, you can recover the state of the computation because you are maybe persisting that on a database or something, or is everything in memory, or what?
I'm just trying to remember because mine crashed quite a few times because when I was just trying and trying and trying and just like crushing things. Um, I think I'm not, I'm not really I don't I just have to think how it was because on locally I wouldn't really expect it to store that much, but it does store some temp files and everything, but I don't really remember right now if it's using those temp files or it just kind of overwrites them. But I would expect something a bit more kind of robust on the in the cloud. So if you're using in the cloud, it stores things to the database and has the temp files and everything. I think it actually knows how far it got, because like if you actually, I would say yes when I think about it, because I'm just trying to like kind of track back to what happened to me. And the thing is that when you run all those examples, like every time you run them, it takes shorter and shorter and shorter like amount of time. And I'm pretty sure that's because it actually remembers where it is and kind of continues where it picks up where it stopped. But don't really quote me on that. I think it is like that, and I'm trying to think what happened when I was running this thing, and I think it was like that. But try it out. I think again. I mean, think.
Yeah, have a look at
Yeah,
the
just have a look.
documentation.
We
Yeah.
can check it out afterwards as well, after the talk
Mm.
as well. Just take a quick look.
Okay, thanks.
Hi. I arrived later, so I don't know if you talk about that or not. But what's the advantage of using Apache Beam instead of Spark, Flink, which are the engines that are running under the hood? Because, for example, with Flink, or I think with Spark you can do that, but with Flink, the problem with the recovery is very clear, because you have total control out of that. But in Apache Beam, I don't know if this is which kind of abstraction.
Because, well, I mean, I haven't used that much Apache Beam and Spark myself, but the thing is that usually it's a bit more tricky to build up those pipelines. Here, I mean, my experience was when I've never used things like that. I've never tried anything, and usually I would end up writing a Python script or something to parse the data for me, and this was a very simple way of parsing. I mean, the whole code is just one file, and most of it is just like picking up some configuration and stuff like that, and the whole magic kind of happens in this is options, so this is kind of way of providing options, and this is process also debug data. So this is pretty much the whole thing that happens, and this is very kind of simple, and there is a lot of magic things happening. And the cool thing is also that it integrates with Apache Beam and I mean all those things. So you can Hadoop also, because you store data on like some kind of distributed thing, because you have some kind of huge amounts of data, and you can just suck it out of wherever you store it, and you process it. So to me, that was kind of appealing, was that it was very simple to read and write and create the pipelines that kind of can scale up and down without really having to think about that much. Because with Beam and all those, I think you have those what's the job names? You have like what's it? Peak jobs, isn't it? Like you have like a bunch of jobs that you have to create, which are a little bit complicated, and you have to make sure that they run, and you have to kind of run them on local, on your kind of cloud or your machines and everything. So that was, for me, it was, but well, choose your poison really, because I mean this is one of them, but you know it has some downsides. Then use something else. But this was kind of my experience of trying things out with little experience of things, and it just worked. And I was like, for me, it was lots of kind of surprising moments where I was like, this is too simple, this should not work. And then you look at the data, it's like, huh, it actually processes it and it actually gives me back data I want. Cool.
Great, thank you.
Okay. So, well, just to show you a little bit of code. This is just comments, so this is more kind of where I put things and everything. This is main, this is not really interesting. This is pretty much where the magic happens. Well, this is some configuration stuff, and I kind of created a few configuration parameters so I can like read the data from where I read it, where I store it, and I have like one I put it on a local file, the other one where I put it on into the database, and actually one of the points with the Apache, well, like not using just something like Apache Spark or anything, is that you can switch things so easily. You can just, you have all those connectors that are ready for you, and I think it's a bit more tricky if you usually you just have to kind of keep it within the Apache Beam, whatever, walled garden kind of thing. But here you can just like, oh, well, I want a file. Okay, fine. You just add a parameter, say file, and it will be fine. And one database, you just add another parameter. It just happens to run on a database, and it's kind of nice. So a bunch of parameters, just like options things. So it's not really, you don't really have to do those. And there is more. What is this thing? Yeah, this is the code I showed you, extract from JSON, and if we go, oh, it's really fun. There, yeah, and as I told you, this is where all the extracting happens, right? So you just process element, you just have one element in my kind of world is a file, and then I do some stuff with it. I just like put it all in a map, and then I just kind of read data from it, and then so this is a super primitive way. In Java, normally you would end up creating some kind of persistent data structure. You would do some more kind of advanced things. If you wanted, you would kind of persist all the whole thing into, or well, put it all thing in a class and then some kind of data structure and do some magic. I had a really small amounts of data and very kind of structured, well-structured data, so I didn't really do that. I did it almost like you would do normally, I don't know, in a Python script or something. Just like dump the whole data, put it in a map, and just do some magic with it and do it. Because for me, it was just like getting it done, and without creating like super enterprisey kind of Java version of that, which I could, but well, you know, now I have the good thing. Now I have one big file containing all, but well, you know, and it has a pretty okay README, which you'll see on GitHub, which explains how to run it in locally when you have it on some Google Cloud, and with what you have to do to make it run. And I even included some kind of example files here in resources. This should be like a tiny little piece of data, just so to get you started. Yeah, very nice, without like formatting and everything. It's just like one big line. It's a very long one. All right. I think if you have any questions, any comments, or anything, this is me on Twitter. This is me on a bit kind of more traditional social network called email, and well, this is me online anyway. So, and well, I guess we can chat afterwards here, and we have a couple of things to check out in the documentation with a few of you guys. So it's going to be fun. Thank you all for coming.
Thank you.